Sanskar, I want to ask one question related to it. Can you tell the interaction parameter, which interaction parameter will be positive or negative when congruent phase forms? Can you relate interaction parameter with the phase diagram?
Sir, congruent phases are, as such, are mainly seen in compound formations, like when line compounds are formed. Thus, the interaction parameter should be means much more less than zero in case of congruent phases formation, so that we get
Okay.
compound formation.
Okay. So can you draw that diagram? Phase
Of a
diagram.
congruent phase.
You can take, let's take isomorphous diagram and interaction parameter is highly negative.
Okay.
Okay.
So this is the diagram, sir, where this point is the congruent melting point, and here the interaction parameter in the alpha phase is highly negative.
Okay. So why this solidus line is going up?
Because when the inflation parameter is highly negative, so the delta H value decreases, and due to which the delta G value decreases. And as we know that when the change in the Gibbs field energy is very negative, then the stability of the phase increases highly, due to which the region or temperature till which the stability occurs of the alpha phase increases. Thus, we get stable alpha phases in higher temperatures.
Okay, there is one more case in which that liquidus go below and it intersect solidus. Okay.
Yes, sir.
So can this congruent phase form in that case when liquidus go down and intersect solidus?
Yes, sir, it can form that point also.
Okay, draw that diagram and tell me what will be interaction parameter for that in liquid and solid state.
So this will be the diagram, sir. And in this case, the interaction parameter of the liquid of A and B in liquid will be negative, and the interaction parameter of alpha will be nearly equals to zero.
Okay, so you are saying compound formation can occur even in this case, right?
Yes, sir.
So are you sure about it? Interaction parameter of solid is considered or liquid is
So,
considered?
sir, compound will not form. Sir, congruent melting can congruent phase can form, but compound formation we need the interaction parameter of alpha to be much more less than zero,
Yes,
not
yes.
of the liquid.
Okay, fine. Okay, so tell me, Sanskar, what is uphill diffusion?
So in uphill diffusion, the diffusion occurs against the concentration gradient, like from the lower concentration gradient to higher concentration gradient.
Can you give some examples of uphill diffusion? Any example?
So uphill diffusion is usually seen in spinular decomposition that occurs when the omega of the alpha phase or the solid phase is greater than zero. Then we get for a region called spinal decomposition where we can see uphill diffusion.
And any other example apart from spinodal decomposition?
Sir, when we do welding of the different steel samples, so it is possible that in one sample there is more chromium, and in another sample there is less chromium. But as the chromium is present in form of some compound like maybe chromium carbide, thus the chemical potential of the chromium is less in the steel where the composition is higher, due to which the means diffusion will occur from the scale of lower composition to higher composition due to chemical potential effect.
Okay, Sanskar, another question which is from precipitation. Some question is already asked to you earlier by Sanjeev from precipitation. I want to ask some more question. In precipitation hardening, okay, so there is very popular curve which is hardness versus aging time. So can
Yes.
you draw it and also tell what is the procedure of precipitation hardening, heat treatment, precipitation heat treatment? Tell both the things. Okay.
So this diagram is the diagram of hardness versus time for the different
Okay, okay.
temperatures.
So why you have shown three
And
temperature?
so,
I have not asked that to show at various temperatures. I just asked you to draw the variation of hardness versus aging time. Okay, it's fine. It's okay. It's
okay.
correct. So you have means already shown the variation of curve with temperature. So which temperature is higher? Can you show again? Which is higher temperature?
So the lowest temperature, that is at T3.
Okay. So tell me why the peak hardness is reducing with increase in temperature.
So as the temperature increases, so first of all, the aging time is less, due to which we get lower time for diffusion. The other thing is that grain portioning can also increase, and due to this grain portioning or portioning of the precipitate size, the number of precipitates will be less, and the size will be higher, due to which we get lower hardness.
Okay. So is there any other factor which will affect peak hardness apart from temperature?
Sanskar, you check the phase diagram. You will get your answer there.
Sir, composition. The composition can be one of means the composition of the steel
Okay,
or the
okay.
composition
So
of the metal.
can you draw the variation with the taking some composition? Let's take one composition, 1 weight% copper, another is 2 weight%, then 4 weight%. Let's take 4 or 5 compositions and draw how the curve will change.
Same heat treatment process, right? Like same precipitation process, only compositions will be changing.
Only composition is changing. Okay.
Okay.
Composition of copper is changing, let's say.
In
Let's
aluminum
take
copper system.
aluminum copper system. Let's take aluminum copper
Okay.
system and composition of copper is changing. Temperature is fixed, let's say. I'm giving the hint, temperature is fixed.
I think it should be like this, sir. So here I have assumed that just before 3%, the transition from alpha phase to alpha plus beta solvers line is there at the temperature. So below that, there will no change in the hardness or temperature, as we are getting a single alpha phase, and after that we will get the alpha plus theta phase.
Okay, so can you show it again? Just you have taken two composition, no?
So here I have taken 1% and 2% copper, and this is 3% copper
Okay.
and 4% copper over it.
So why the 4% is showing more hardening?
Sir, in the 4% is showing more hardening because like the amount of solubility of copper in alpha is same, but we are increasing the composition. That's why we have more amount of copper, means copper present that will go into CuAl2 and more theta phase can form.
Are you sure about it, or there is something different called GP strengthening, GP zone formation strengthening? GP zone will form in both cases, or it will form it forms for a particular composition.
No, sir. GP zone will not form for all the compositions, sir.
It will not form,
Like
no?
it will form with for a very means not only at the exact same composition, but a very narrow composition, I guess. Very narrow composition range. And usually
What is
we use
that
a
range?
4.5
Do you know what is that range?
No,
Range
sir.
for
I know
GP
that
zone formation.
it is near to 4.5%, but I don't know the exact range.
Okay,
We always take 4.5% composition copper.
okay. So, Sanskar, suppose if we are adding copper in aluminium, so the let's say alpha solid solution is forming. So, will there be change in the lattice parameter by adding copper in alpha? Sorry, copper in aluminium or copper in alpha, let's say.
Yes, sir.
So,
When
how
it
it
is in
will
the single
change?
phase, then when in single phase, then the lattice parameter of alpha will increase.
Alpha lattice parameter of alpha will increase. Are
Yes,
you
sir.
sure
Like
about it,
I think
or it
so.
depends
I think
on
it actually
some
depends
factors?
on, yes, sir. It depends on whether the lattice parameter of copper is more than lattice parameter of aluminium, or it is less than lattice parameter of aluminium.
Okay, suppose if I give you this hint, it is lesser. Copper lattice parameter is less compared to aluminum. So can you show the variation of lattice parameter with the weight percent of copper just below? Listen my question first.
Yes,
Just
sir.
below the phase diagram which you have drawn. Okay. Show how the variation of lattice parameter will occur for aluminum copper system from single phase to two phase. Okay.
I will need some time, so I will draw the phase diagram
हाँ,
again.
draw the phase diagram first, and below it draw variation of lattice parameter with the composition of copper.
So assuming that the lattice parameter of copper is less than lattice parameter of aluminum, right?
Yes, yes, correct. Say something, then it will be visible
Okay.
to me.
So this is the phase diagram. So as we can see that in the alpha region, we
Hmm.
can see that the lattice parameter of alpha is decreasing with increasing
Hmm.
copper percentage. And once we hit the alpha plus beta region, as we know
Hmm.
that in the alpha plus beta region, the composition of copper in alpha is remains constant. Thus, we can say that the lattice parameter of alpha will remain constant as there is no change in the
Yes.
composition of copper in alpha.
Very good, Sanskar. Just one more question. in this aluminum and copper were having same crystal structure, right? Crystal structure
Yes, sir.
was same. But
Yes, sir.
why the lattice parameter is still affected by adding copper? Both were having same structure, FCC structure. Then how the lattice parameter is affected by adding copper in aluminum?
So because it is not only the structure, means crystal structure that affects our means plate parameter. The atomic size of aluminum and
Yes,
copper are different.
very good with this question. Okay, very good, Sanskar. So, what I feel in this interview that you are very, very well prepared, okay, for the interview, and you have great chances of selection. Okay? Just a few suggestions. One is avoid over explanation in those topics which you know very well. Like when I asked to draw that hardness versus time, na? So you have to just show it. Don't show it with the various temperatures, okay?
Temperatures.
With
Yes.
different temperatures. And second, when you know any answer, still take some time, okay? थोड़ा सा time लो, फिर उसको आप answer करो, okay? Yes, Sandeep, any suggestions from your side?
हो जाएगा सर, हो जाएगा.